Today we are going to start quantum numbers in chemistry. So what are quantum numbers? Quantum numbers are basically the numbers which tell us everything we need to know about an electron. Okay, so let's just erase this quickly. Okay, so numbers which identify the state of an electron, or specify the energy that is associated with it, or with the state it is in, or its position with respect to the nucleus and designate and distinguish them into atomic orbitals. All right, so basically there are four types of quantum numbers, namely principal quantum number. I'll just denote it by n. Azimuthal quantum number, denoted by L. Magnetic quantum number, denoted by M. And spin quantum number, denoted by S. So let us study each of them now. So basically, principal quantum number is the number that represents the main shell to which the electron belongs. Okay, so principal quantum number specifies the main shell it belongs to. Main shell, as in we know that each shell has subshells. Okay, which we will study in this section. So basically, let us say this is a nucleus, and let us consider this element K, L, M, and these are the shells. So for these, n equals 1, 2, 3, 4. Alright, it's just the main shell, and O will be 5, and so on. So the first energy, n equals 1, which is also equal to the K shell, is the nearest to the nucleus and has the least energy. The energy of the main shell increases as the value of n increases, meaning, so as the value of n increases, the energy the energy increases with the value of n. Alright, and each main shell has 2n square electrons, meaning K, let us consider K has n equals 1, so 2n square for K is equal to 2 into 1 square, which is equal to 2. So K will have 2 shells. Alright, moving on to the azimuthal quantum number. Quantum number is also called the secondary, subsidiary, orbital, or angular momentum quantum number. It is represented by the letter L. So this basically represents the subshell to which an electron belongs. Okay, it belongs to the subshell to which an electron belongs. It defines the shape of an orbital, and it ranges, so the value of L is related to n, okay, in some way. So basically the value of L can have ranges equals n minus 1. Okay, so let us say for the principal quantum number K, okay, so K has n equals 1, so it will have L 0. Okay, it has values from 0 to n minus 1. So L has values from 0 to n minus 1. So you have 0 to 0. Or consider this. Now wait. KL. L has n equals 2. So L is equal to 0 and n minus 1, which is equal to 1, and so on. So this is basically the number of, this defines the subshell to which an electron belongs. So we have a table designed for that. So value of L. Wait. Of L and the subshell. Okay. So basically when for K, wait, we have this, this is N, L and the subshell. So where N, K equals 1, L equals 0, the subshell is called as S. Okay, we will get into the details. L equals 2, 0, n minus 1, 2 equals 2 minus 1 equals P. M equals 3, 0, 1, 2. So this has subshell S and P. This has subshell S, P, D, and equals 4, 0, 1, 3, 2, 3, S, P, D, F. So what are SPDF? So an SPDF is basically the subshell, okay, or the orbital. What is the difference between a subshell and an orbital? So basically a subshell or an orbit is basically the well-defined circular path, and this is for an orbit, around which a nucleus revolves, okay. But an orbital is basically the three-dimensional space in which the probability of finding an electron is the highest. So this is just rough. Okay, wait. Alright. So this is the orbital, and an orbit can accommodate 2n square electrons, whereas an orbital can accommodate only 2 electrons. And orbits are basically the path, and this is a three-dimensional space. Alright. So this is between orbits and orbitals. Now we move to the